Welcome back. In the last video, we covered the first question of the 2018 AP Chemistry exam, and now we're going to move on to the second question. So let's get started. Next, N2O3 reacts with water to form nitrous acid, HNO2 aqueous, a compound involved in the production of acid rain. In the reaction below, the skeletal structure of HNO2 molecule is shown in the box below. Complete the Lewis electron diagram. So the easiest thing for this one is to draw in the number of electrons, and then you can create your bonds after. Okay, so if we draw in our electrons, we know that hydrogen wants to fill up its shell so that it has 2, so that's its S shell. Oxygen, his S shell is already filled, but he wants 2 more so that his P shell is filled as well, and nitrogen wants 3 more as well. So oxygen needs to have 2 bonds, hydrogen 1 bond, and nitrogen 3 bonds. So using that information, if we start out with hydrogen, it needs 1 extra bond, right? So there we go. We have one electron from hydrogen and 1 electron from oxygen to create that bond between them. Now we said that oxygen needs 2 more bonds, 2 bonds to make it happy, so it gains 2 electrons. So it has 1 from hydrogen. This oxygen has 6 electrons that it had previously and 1 from there. So we draw in 1, 2, 3, 4. It has 1 from that bond, and it's going to bond with nitrogen to create its full valence shell. So now it has 8 electrons around him. That oxygen is happy. Okay? Now, this oxygen now, we'll go in order. This nitrogen, it wants to gain 3 electrons, therefore it has to create 3 bonds. Now, this oxygen is already happy, so this nitrogen can't create any more bonds with this oxygen. Therefore, the other 2 bonds have to occur with this oxygen. Alright? So it's used up 1, 2, 3 of its electrons from the 5, and now it'll have 2 more left. Okay? So nitrogen is happy. It has its 5 electrons from itself, and it's gained 3 more by bonding. Okay? Next, we move on to the final oxygen. So we have to make sure that he has 6 electrons of his own. So he has 1, 2 from those bonds, 3, 4, 5, 6, and he is happy. Okay, that's your complete Lewis electron diagram. So now the next question. This is based on your complete diagram above. So this one here. Identify the hybridization of the nitrogen atom of HNO2. So the hybridization is basically writing out what they would look like. Because all your elements, we write them out linearly, but in real life, they're in a 3-dimensional shape, and hybridization is basically when we write out what shape it will take. So that's based on how many groups of electrons they have around the element. So, for instance, H will have, because it's only bonded to the O, it would have 1 group. Okay? So if it's 1 group, it's just S. Oxygen has 1, 2, 3, 4 groups, so it would be sp3. So 3 groups from the P and 1 group for the S. So when we're looking at your nitrogen, basically we are asking ourselves how many groups of electrons are around it. So you have this part here, which is 1 group, this part here, which is 2 groups, and you can't forget the lone electrons. That's 3 groups. Okay? So you have 3 groups of electrons, which means that the hybridization will be sp2. Okay? So there's a table that you can learn that basically, as long as you can figure out the number of electrons that you have around an element, not single electrons, but groups of electrons, then you can figure out the hybridization. So for nitrogen, because there are 3 groups, it's pt2. Last little bit. So to produce an aqueous solution of HNO2, the student bubbles N2O3 into distilled water. Assume that the reaction goes to completion and that HNO2 is the only species produced. Determine the concentration of HNO2 aqueous in the resulting solution. To determine the concentration, the student titrates 100 milliliter sample of the solution with 0.1 molar KOH. So the following titration is here below. So E. Using the titration curve and the information above, determine the initial concentration of the HNO2 solution. In order to do that, we need to know how much KOH was added when the reaction stopped. So that is here. Okay, so this is the reaction occurring when it's at the flattest. That is when the buffers are equal, and then it'll continue until it's completely saturated here. Okay, so that's 20 milliliters. So we want to know the initial concentration of HNO2. If we can figure out how much KOH was added for the system to be completely saturated, then we know how much HNO2 is there, because that means that all of the H's from the HNO2 have bound with the OH minuses. So in order to do that, we know the amount of KOH that was added, which is 0.002 liters. If we know how much we have, which is 20 milliliters, that is 0.02 liters of KOH. And now we want to figure out how many moles we have. So to do that, we can use the concentration, which we know is 0.1. So that means that there are 0.1 moles of KOH in every liter, which means that we have 0.002 moles of KOH. Okay? Since we know that KOH has one OH minus and HNO2 has one H plus, they're going to be a 1 for 1. So we know that 1 mole of KOH would bind to 1 mole of HNO2. Therefore, we have 0.002 moles of HNO2. Now, to find a concentration, that is the number of moles over the volume. So we know that we have a 100 milliliter sample. So our concentration of HNO2 is equal to 0.002 moles over 0.1 liters. And that is equal to 0.02 molars HNO2. So that is our initial concentration. Okay? So now we want to estimate the value of the pKa for HNO2. The pKa is the pH of the equilibrium constant of the acid. Okay? So the reason why K is the equilibrium constant, A means that's for an acid, and then pKa is the pH at that point in time. So when you are at equilibrium, that is when the system is happy. Both sides are happy. So the amount of acid and the amount of buffer that you have are relatively equal. Okay, and that is said to be the flattest part of the curve. So it would be around here. Okay, but just at about 11, 12 milliliters. Okay, so we mark it right here. So that's why it says estimate, because that means they want you to use the graph. If they say determine, they want a calculation. Estimate, it means that you shouldn't be doing any math. It should be from the graph. Okay, if you freak out during your exam and you start doing some math for this question, you're taking way too long and you're going to be wasting your time. So if we just try to make a line to there, that's just above 3. It's quite, that's a little bit too high actually. Just above 3, okay? So we can estimate that the pKa is approximately, let's say 3.4, okay? Because it's not actually, it's about just under halfway between 3 and 4. So when they say, be careful with the wording. When they say estimate, they're not looking for calculations. It means that there's something in the information given to you that you can extrapolate information for. Well, I guess in this case, interpolate. Okay, moving on. During the titration, after volume of 15 milliliters of 0.1 molar KOH has been added, which species H, NO2 or NO2 minus is present at a higher concentration in the solution? Basically, we're saying we are here on the graph, okay? We are above our equilibrium. If we have our equation H, NO2 plus OH minus goes to NO2 minus plus H2O, we're saying that since we're above equilibrium, we have shifted more to the right, okay? If we are down here, that means we have more on the left. At equilibrium, they are equal. On the right of equilibrium, we are further along, okay? Which means that you're gonna have more NO2 because you have gone past equilibrium where they would be equal, and now we're on the other side. Okay, so what we can say for that is NO2 minus will be at a higher concentration because at 15 milliliters we are past the point of equilibrium. Therefore, the products are greater than the reactant. Okay? Yes, so that's the last part of question 2. And I hope you found this video useful. For more videos like this, please be sure to subscribe to our channel, the link to the right. If you are looking for some one-to-one help, check out the link in the description below where you can have test lessons with either myself or another member of our AP team. I hope you enjoyed the video. Thank you so much for watching. So 1, 2, 3, 4, 5. That's not too bad way of showing it. We end up with concentration of, oh shit, videoing myself is very stressful.